Now recording. So, there's this week, and then there's next week, and then there's the exam. This week, we are covering REST APIs, APIs in general. Our material that we've talked about with MVC will have, it's supporting this material, basically. Once we're through this, that's it. This is the last topic in the course. And I'll show you where we sort of cut off in these slides so that you guys can have some, part of the purpose of next week is to give you guys a very solid idea of what the coverage, what the material covered for the exam will be. But, I'll give you some hints while we're going through this. So, any questions? Okay. So, we are to talk about cloud computing. So, can anybody offer me a definition of cloud computing? What is cloud computing? It's fake. That's, yeah, I mean, cloud computing is certainly a marketing term. And, being a physical scientist, I must regard all marketing terms as being fake on one level or another. It is certainly fake in that there are no actual clouds involved in cloud computing, although there is computing going on in cloud computing, so they have that. Anybody else? Yes?
Delegating some kind of task to a computer that is elsewhere on the network.
Yes, delegating tasks to computers that are elsewhere on the network. Yes, so this is part of the problem with the concept of cloud computing is, to an extent, that definition is also served by traditional client-server architecture, right? Cloud computing is kind of a little bit more than that. Anybody else have anything they'd like to throw into the bin, throw into the hat? I'm only asking because I don't know myself what cloud computing is. No? Okay. So, so cloud computing is at this point synonymous with services offered by the big cloud computing vendors. Cloud computing is a product, right? Who are the big cloud vendors?
AWS, Microsoft, Cloudflare.
Cloudflare and
Google.
Google, of course, yes. Microsoft, AWS, Google, and Cloudflare. Of these four, 3 have had major outages in the last month-ish. Which is the one that hasn't?
Google.
Google. So, it'd be very interesting to open up that can of worms and see how much AI the Google folk are actually using in their production code. All right. What we're really talking about, though, when we're talking about cloud computing, is like there's a kind of a different philosophy of the internet, which took hold, 15 years ago now-ish. So this is the way that I like to explain it, right? You've got the historical internet, and then you've got the contemporary internet. The cutoff there, you can make arguments about it, but I think it's around the time that the iPhone came out, right? So prior to the pivot, the internet was primarily conceptualized as a large distributed file server, right? The primary purpose of the internet was to issue web pages, right? You have your HTML, you have your CSS in the form that it existed, 20 odd years ago, and you have your JavaScript. JavaScript is absolutely not a language that people take seriously 20 years ago. JavaScript has made a lot of progress in the last 20 years in becoming a serious language for serious people. But that's primarily what you're on about in the historical internet. Your client connects to a server looking for a file. The server issues that file. The client then does some processing, presents you with the files in one form or another. This is the classical internet. This is the internet as it was originally conceptualized. Make sense? This is, for the most part, the internet that we have been learning how to program in this course so far, right? And it's, I know I give this course a lot of stick, but to give this course some credit, the internet still very much is a big distributed file system. These functionalities are not going away, nor will they ever go away. No matter, it would take a pretty radical alteration in the structure of the internet to no longer be interested in serving HTML, right? But in the contemporary internet, I'm trying to avoid the use of the word modern because the problem is that, the word modern is terrible, because a lot of people define the word modern to mean contemporary, right? Happening at the moment means modern, but that's not actually, that's not a good thing when you name, an intellectual movement after it's the thing that's happening now, because then there's no actual end to modernism. But anyway, so contemporary is a better term for it, right? Happening at the same time we are happening. So the contemporary internet has shifted away from this concept of the internet being a gigantic distributed file server. We have very much entered the age of the API, right? API, that's a term that all of you should be familiar with, right? How many people have heard of an API? Okay. For those of you who are on your phones, an API stands for Application Programming Interface. Now, that is a very general term. Part of the problem with software is that you have one term defined 6 different ways in 6 different subdisciplines, right? When you're programming in Java, you still have the concept of an API. What is your API?
The method parameters?
Not just methods, but what kind of methods? The blank methods of a class?
The public?
That's right. The public methods of the class are the interface to that class. It is your interface for programming an application programming interface, if you will, right? So, that's fine. People sometimes use the term API in those terms. What we are talking about in web is something considerably different, right? What we are talking about is the use of a server as if it were a class in Java. With a great big asterisk, that's a very, very, very high level description of what we're doing, right? But the concept is that you have a server and you call functions on it, essentially, right? You call a function, send it some data, you receive the output back, right? This is the concept of a web API. Now, in actual, practical terms, much of the time, an API is some kind of middleware layer that allows a user access to a database, right? This is primarily what a good chunk of APIs really are, right? By saying an interface, a middleware layer that allows a user to interface with a database, I have just described Twitter/X, I have described Facebook, I have described Instagram, I have described Snapchat, I have described WeChat, I have described YouTube, I have described all of those dating websites, scum of the earth that they are, right? All of these things are users interacting with databases through a middleware layer, right? Now, the question is, how directly do you wish to do it? In the case of your, our ever, how do you want to say, the normies of the world, bless them, those nice, lovely normies who know nothing about programming, wouldn't know an API call if it, stole their lunch and ate it in front of them. Normies need some web forms because they don't know how to program. We know how to program, so we don't need web forms, right? We can write programs to access other programs. We can write programs that launch that launch HTTP packets at servers. The server collects up the HTTP packet, processes it, produces the output, whatever that output may be, sends that in the response packet, and the client, whatever that client may be, does whatever it needs to do with that data, right? We no longer are in a realm or a world where clients are exclusively web browsers, right? Up to this point, clients have been web browsers. We have been issuing HTML, CSS, and JavaScript. Let me illustrate with an example. How many people have heard of the Internet of Things? Quite a few of you. It's a buzzword that was popular among business majors, etc. about 10 years ago, 10, 15 years ago now, somewhere in that range. It was occurring around the time that the AR, VR, that was also a big buzzword in business at the time, right? Basically, this is how the business cycle works, right? Some engineers ooh, we could do this. Unfortunately, they say that within earshot of a business person, and the business person is I see potential businesses, most of which will fail, but a couple of them will survive. This justifies billions of dollars in investment in a sector that doesn't exist, so that maybe 2 companies can survive it, right? This was what the dot-com bubble was originally. This is what AR, VR was. This is what IoT was. IoT particularly, because you can actually sell consumer goods with it, right? They tried doing this with blockchain, but blockchain was too hard, so they all stopped. And now they're trying to do it with AI, and that's another category of products that you can sell in theory. Right now we're in the middle of the AI boom. There will be a bust at some point. The stock market is going to lose untold trillions of dollars, and that's welcome. And that's how it's going to go. Just like what happened during the dot-com bubble, and everybody lost their shirts, and 2 or 3 companies emerged as the big guys after the end of the dot-com bubble, right? One of which was Google, another one of which was Amazon, right? So, yeah, this is how business works, right? You throw all kinds of money at an idea of marginal utility in the hope that a couple of companies form that actually, basically these companies, the untold trillions of dollars that business shoves at ideas is like the womb in which you grow something like Amazon, right? So anyway, a number of business cycles ago, we had Internet of Things, right? The general idea, like the engineers, ooh, what if we did this, that caused all of that, was, what if we put a Wi-Fi module in a toothbrush, right? In and of itself, you know, we have Wi-Fi chips now, they're miniaturizable. We can put them in things. We can put them in lots of things. What if your toothbrush was a client on a network? We could do stuff. We could connect interconnectivity. We could have the data flowing. And of course, evil business people were like, we could know how many times a day people brush their teeth. We could use this to market toothpaste to them, right? And of course, I'm constructing a bit of a straw man because, like, my traditional straw man for IoT is the Wi-Fi enabled toothbrush. It's like the thing that nobody needs, right? There are a couple of things that have kind of become persistent out of the Internet of Things boom. The smart home thermostat seems to be a thing that's persistent. Although I think I've never heard anything but complaints about the Wi-Fi enabled light bulbs, which just seems like a terrible idea on the surface of it, you know. But like, here's a light bulb. It's 4 times the cost, and you can control if the lights are on from your phone. It's like, but I'm in the room that I want the lights on, so I could hit the switch which already exists. It's like, no, you can do it on your phone. It's like.
Also, opening the app and pressing the button takes longer than just walking over and pressing the switch. Ask me how
Right.
I know this.
And in one of these 2 ways, you get your cardio in, right? As much as walking to a light switch constitutes getting your cardio in the year 2025. So it certainly counted as cardio during COVID.
But my accessibility.
And so, I mean, okay, all right, yes, there are like corner cases where such technology would be useful. That I'm not denying, right? What I am denying is the general utility for people who don't need it, right? So, last Father's Day, I got a thing like this for my father-in-law, all right? It cost way too much money, but it was a meat thermometer, right? The meter, you guys have seen these things, yeah? So, basically, kind of the big advantage of it over a normal meat thermometer is that, like, it doesn't have like a probe line that you have to have like coming out of your stove, right? If you want to time your roasts, like you don't need AI to time your roast, right? But like, you know, it's like it's a cordless meat thermometer that communicates with your phone. It's fine. My father-in-law really liked it because he's a big barbecue guy, right? As many men are, and you know, I have a question for you. If a meat thermometer is the client device, do you issue it web pages? No, for it lacks a monitor or a screen or any kind of display device whatsoever. There's no way to view a web page on a meat thermometer. Clip that for an out of context clips. So what do you issue it then? Right? Well, not much, right? It's fundamentally a transducer. So it doesn't really require any information for its operation, except perhaps to turn it on and off again, right? So, what the thing is doing is it's sending a stream of data via HTTP requests to a server. It's bouncing them to a server. It's then, that server is then bouncing statistics back to the companion app on the phone, which is also a client. So we're in this strange realm where a single web application can now be composed of multiple asymmetrical clients, right? But how does all of that work? API calls, right? The meat thermometer is making API calls on the server, sending it information. The server is databasing it. I don't know how evil commercial interests could make use of that information. Perhaps it's interesting to them what time of day you're cooking your roasts at. Who knows, right? Well, you also have to like dial in what particular type of meat you're cooking as well, because that affects the cooking time. So yeah, maybe, maybe there are marketing applications.
Maybe you use the meat thermometer and then your phone starts sending you ads about like, oh yes, here's the kind of sauce that's really good for this kind of meat you're trying to make.
Yes, there you go. Very good. Actually, my father-in-law did report that he did start getting kind of slightly creepy emails asking him how his pork chops were. It's like, my father-in-law married into Italians. He doesn't need a computer asking him how his pork chops were. Right? He gets that from his Italian relatives. That's the joke. But this is like the concept, right? When that meat thermometer sends the data, it is sending probably something like JSON, right? It's sending JSON data to the server is sending JSON to the phone when the phone requests that data, right? And you get your little graph of your meat's temperature increasing over time as thermodynamics, right? But that's the concept of an API call. You can write Python programs which make HTTP requests, right? It's quite easy to do in Python. You can write a program in pretty much any programming language that launches an HTTP request. They all have libraries for them, right? So the client is no longer just a browser, right? But even if the client is a browser, let's say everybody's favorite chat algorithm, right? When you're interacting with the infernal chatbot, how many times does the page reload? Right? You are literally making API calls to the chat interface, right? And this is why, okay, all right, okay. Can I give you guys a hint? Here's a hint for your capstones, right? If your capstone is like, ooh, I'm embedding AI functionality by making API calls to the chat engine, not very impressive, right? Quite QED, quite easily done, right? All you're doing is making API calls, right? You're going to have to come up with something a little, not to labor the metaphor any further, but you'll have to find something with a little more meat on the bones if you want to do well in your capstone. So, all right. So, REST APIs then. REST stands for Representational State Transfer. The best way I've ever heard REST explained was in a joke, so I will now tell the joke. A person says, oh, look at this. I did this with a REST API. Another person says, this is not a REST API. A third person says, yes, it's only a REST API if it was developed in the REST region of France. Otherwise, it's just sparkling JSON. Oh, that's a shame. I was hoping for at least a couple of chuckles. It's a joke about champagne, how you can only call it champagne if it's grown wined in champagne, right? Otherwise it's just sparkling wine, right? So basically there are no hard and fast rules with REST APIs, right? There's a general way that they're expected to work, but these operate as guidelines mostly, right? So there are a couple of important things. Some of them we've touched on, some of them we haven't. Number one, information can be derived from the route in the URL of the request. We've already seen how to do this, but this is an essential element of REST APIs. Number two, up to now we've had a very, shall we say, first year of the program understanding of request methods, right? Request methods have semantic meaning. In a REST API, we try to use our request method to indicate the type of request we're making. Up to this point, we've kind of just loaded everything into GET requests, right? But, GET requests, POST requests when we need a little more security, right? But this is fundamentally this is like one of those cases where you know how in like high school chemistry you learn about the model of the atom with the rings around it, and then if you go to university they'll say, oh no, that's okay for high school, but here in university, what we have around an atom is a cloud of probability of where the electron might be, and it's that's a lot more complicated than the high school version. This is kind of one of those things, right? GET requests, POST if you want security. Each one of our requests has a specific meaning. We try to use things according to their meaning. Another important element of REST APIs is properly using your response codes, HTTP response codes. Your response codes should indicate whether there was an error and what sort of error there was, whether things executed normally, right? Up to now, even as recently as last week, when we wanted to indicate an error to the user, we just kind of wrote an error message and quit, right? What we need to do is use an HTTP status code to indicate what kind of error that was. There are lots of them that you may not think would be very useful, such as payment required is an HTTP status code. But if you're charging for the API, right, payment required might be a perfectly valid, response. Maybe if you exceed the number of API calls that you're allowed in a certain time frame, returning payment required for the rest of them is exactly what you would want to do. So here is one of the business cases behind the API, right? It's a service you can charge for, right? Many people, don't. Some people operate these things out of the goodness of their hearts. Some people operate these things because they understand that the data they're harvesting from you is of more value than your subscription. But some people will require a subscription from you. For example, there is, this is probably old information now, but you can pay for API access to Twitter/X. And, if you pay them honestly earned good hard money, you can get API permission to post 1 million tweets a day, which seems like too many, but it's like the spammiest of all spam accounts, but yeah. Yes. Another thing that we will often do in REST APIs, the body of the packet itself will become like just a chunk of JSON. Prior to this, we would put chunks of JSON, we kind of like fudge them in as, you know, query parameters and post parameters, put them in the body by making it a post parameter. But it is possible to just simply encode JSON in the body, send it that way. It's not a post parameter, it's just the body of the message, right? This is sort of a simplification that's made under REST APIs. Make sense? Questions? All right, no questions at all? Okay. So, being able to read tables like this is important. All right? I'll even waggle my eyebrows when I say that. This is important. You may even see this in a couple of weeks on a particular document that I'm still in the process of writing. You'll see things like this. So, this is a specification of the API, right? This table tells us what API calls our web application presents to the world, right? So, here we have 3 columns: method, URL, and description. Again, methods actually mean something now. So, more on that later, but you will see different methods in different rows. You will have the route of the URL. Sometimes those routes contain data which is meant to be parsed and thrown into a variable, possibly then passed on to a database. In routing strings, where the colon occurs, that means that this is an actual variable. If there's no colon, this is a string to be matched. If there is a colon, this is a variable to be parsed out. Make sense? In other systems, such as Node.js, you can actually more or less enter these strings directly. In PHP, because PHP is PHP and PHP is the worst, we have to split these apart with explode to extract the individual parameters. Then we must know here that there's a thing that we, like if we get a parameter here, oh, this is the version of this that includes the student number. Notice that in this case we're getting 2 different functionalities for the 2 different routes which may be provided with a request. If we are accessing my API student ID, this retrieves a list of all valid student IDs. For this example, you can presume that, credentials would have to be established, and let's just imagine we have an active validated session, right? So that we could access, this seems like a major security vulnerability to just be able to request all of the students' IDs from the database, right? You should have access and permissions, but let's leave that aside for the time being, right? We've already talked about that enough in this course, eh? So if we get it with two parameters, being my API and student ID, it simply reveals a list of all students. If we provide a student number, this gives us information for a single student ID, presumably more detailed information. I want the information on this student, please. Right? But you can see, it's the form of the route that makes that very important distinction, and those are very different calls. Make sense? Any questions? So, we've already done some examples of how to extract things from the route. Again, in many frameworks, this task is made considerably easier. In PHP, we're bumped down to the level of doing like Java or string level, or Java or C level string processing to get these things out. In many places, this is a more automated process, but the fundamentals of it remain the same. It's just how much work do you have to do yourself, right? So, this next topic is something that is hyper-specific to Apache servers particularly. I can talk to you a little bit about how like Node handles things a little bit differently, but it's kind of interesting when I was like, I'm in the process of this. It's interesting that like where this course leaves off, that's kind of where the Node course has to start. So like the course, like this course is kind of backwards with respect to the Node course, or vice versa, because in order to do anything useful in Node.js whatsoever, you first have to be able to serve packets, and you have to come to grips a little bit with the routing mechanism and how to respond to particular types of packets. A lot of this is sort of built in right from the get-go. Whereas with Apache servers, because everything's kind of like intrinsically a file server, you kind of get file servers for free, right? Where you don't get file server for free in Node, you have to like do specific things to make Node into a file server. But anyway, so within Apache servers, again, Apache servers are file servers. That's how they think of themselves, right? MVC architecture. We have one controller. What is the job of the controller?
Takes in inputs from like views and then sends them to the model
Yes.
to get processed and then send whatever output.
Yes. That's what you were going to say.
Almost.
Almost. What were you going to say?
I was going to say take in data from the view, pass it to controller, take it from the controller, pass it to view. Pass it to the config.
Yes. Those are the internal details, right? But in terms of the interface that the MVC architecture presents to the world, the controller is receiving and processing incoming packets, and it's responsible for creating the response to those packets, right? It uses the model and the view to do so, but fundamentally, we think of the controller as being sort of one point of entry, one point of exit, right? Now, here's a problem. What happens if some clever fellow, some hacker, accesses model.php directly? They won't get much, but they also, unless we do something about it, they won't get an error either, right? They will, in fact, get model.php to execute unless we've protected it from outside interference, right? So, in Apache servers, the mechanism that you are given for restricting incoming packets is called the htaccess file. So, any of my Linux bros out there, what does dot in front of a file name mean? Sorry?
Hidden.
It's hidden, that's right. So the htaccess file is a hidden file, although not in Windows. And it provides a sequence of rules. You can write rules into this thing, which redirect packets inside of the server's file system. So the rules for htaccess operate on a similar basis to gitignore. How many people know gitignore? Yeah, a few of you.
I've seen it.
Yeah. So basically, this is how it works. Let's say you have a folder, htdocs, for example. Let's say that within this, you have A1, A2, right? Let's say that, let's do the actual thing that it actually does. Right? Most of you should have have something resembling this hanging out in your CS Unix accounts, right? When you create an htaccess file, it applies to the folder in which it resides and all subfolders, directories. So if I put htaccess here, this file applies to this folder. If I were to put it here, htaccess, it applies to this folder, and that folder. If I put it at the root, it applies everywhere. And I believe with gitignore, you can kind of mask one with another. But because we're doing rewrite rules here, I don't believe that's possible. Although I will, don't quote me on that. So, this is a very simple htaccess file. The first line, rewrite engine on, simply tells us that we want to enable the ability to modify packets which are incoming. In this way, it's almost like the Apache server itself is performing a man-in-the-middle attack on itself a little bit, because it's basically intercepting the incoming packet and modifying its parameters before it continues processing it, right? It's like a preprocessor step. Anyway, so this turns on the rewrite engine. We then have rewrite rule dot index.php. So I will rely once again on my Linux bros out there. What does dot mean if it's hanging out just by itself?
The current directory?
The current directory, yes. So in this directory, this also means in all subdirectories, we are rewriting the file that we are directing this to index.php. So this means it doesn't matter what the route is that came with the request. All of these packets are being sent to index.php instead of their intended destination. Make sense? Now, things got a little bit more complicated than that when I was doing assignment 4. Shall we dissect the htaccess file in assignment 4 for just a moment? Not that anybody started it, but you know. I'm just a little sad. I worked so hard on it, guys. Everybody's gonna do it, but nobody's gonna appreciate it. There she is. Yes. Okay. I'm gonna get mad at Windows for a moment. Windows can't open this type of file. A couple of problems with this statement. First, it's not true. Second, Windows doesn't open files. Programs running on Windows open files. If it was true that Windows couldn't open this type of file, there'd be no purpose in the dialog. Try an app on this PC. All that means is that Windows doesn't have in its registered data bank of file extensions a stupid Windows program that's associated with it. I hate Windows so much. But they lie to you. They just tell you lies. Like when they say they're shutting down the computer, they're not actually shutting down the computer. Did you guys know that? Yeah, it's like just a deep hibernation state. Anyway. So, this one's a little more complicated. I'll give you the gist of it. All right? So basically the problem is, if all you do is that very simple htaccess file that appears in the slides, you redirect all incoming requests to index.php. But here's the problem. You redirect all incoming requests to index.php. You are redirecting requests for image files. You are redirecting requests for CSS and JavaScript files. It is still true that the server must serve files, even if it's a REST API, if you're doing web application stuff with it, which we are, right? If it was the meat thermometer, then the meat thermometer doesn't need to be issued CSS or JavaScript. Perhaps an htaccess file that simple would be fine. But here we need something a little more. So, basically, we are rewriting the request file name in cases, or we're failing to rewrite the request file name in cases where the incoming requested file has any of these file extensions, right? So JPEGs, PNGs, GIFs, MP3s, JS, and CSS. And we apply that as L, and then if it's not in this case, or after this, if these conditions come out true, we just kind of leave it alone. And if none of that executed, then we rewrite and redirect to index.php. So basically, this is a way of like whitelisting a bunch of file names with particular file extensions. And it's easy enough to extend it, you know. If you just throw some additional file extensions in here, you can expand that list fairly easily. You know, if any of you are working on the assignment and you decide, ho, I'm going to include a clever meme, but your meme happens to be in .avif format, right? This would block it, so you just have to add, like, you know, vertical bar avif in there, and it would work. Make sense? Any questions?
What does the up arrow do for index.php? It's different from the dot.
I don't know. I looked this up, how to do it, without really truly understanding it.
Okay, fair enough.
Yeah.
What language is this, by the way?
htaccess?
Yeah.
No, I mean, that might be the language. It's a little bit bashy. It's a little bit like a bash script, but like, not really. It's doing some of its own stuff. I recognize some of the stuff from bash, but like, yeah, I don't know. Someone's looking it up right now. You're looking it up?
It says Perl compatible regular expressions language.
Bless you.
Perl.
Perl. PCRE language.
Well, that would be that part, certainly, yeah. That's regular expression syntax, but the rest of it? That doesn't look like Perl to me. Yeah, okay.
htaccess files are written in the Apache programming language, and Apache server software is written in the C programming language.
Okay, so it's,
like a mix of a bunch of stuff.
so yeah, Apache, you can get Apache servers that run Perl. Actually, Perl is an interesting language that did a lot of interesting things. It was one of the first to really popularize regular expressions. Do you guys know what the successor language to Perl was? Ruby. Ruby was the successor language to Perl. Do you know why it's called Ruby? It's the month after Perl in terms of birthstones. And do you know what? Nobody really programs in Ruby anymore. Do you know what people program in if they want to do Ruby?
Ruby on Rails.
Ruby on Rails, which people these days just refer to as Rails. So yeah, when you hear Rails, that means Ruby on Rails, which is a framework built in Ruby, which is the successor language of Perl. So I've heard that Ruby on Rails is still fairly employable, actually. It's not a bad one. It's like a smaller one for sure, but not a bad one. So I hear. All right. So there we go. Any questions about htaccess? Is it? Yes? Did you have? No? Okay. Sometimes my classes are like a little bit like an auction, you know? Don't put your hand up. Okay. All right. Oh, that kind of steals my thunder. I was going to do that on board. That's okay. So, request methods. It gets a bit more complicated than this. But we must now expand our understanding of request methods to include CRUD operations. Right? So, we've heard of get, we've heard of post, but we also have methods put and delete. As we can see, these have corresponding SQL operations. So, when we put forward an API call to perform an insert operation, we are posting data. What's kind of interesting about internet lingo is that this actually has trickled down to the level of normies. Because when you are on social media, what do you do when you want to send a cute image of your cat to your friends? You post it. You create a post. A post is like a thing, right? A thing that you put up on the internet is a post, right? And the name itself derives from like snail mail conventions where you would send things by post, right? Post corresponds to insert. If we want to update something, we have the put method for that. Delete is delete as it goes, and get is select. So let me ask you a question though. When we were doing our login verification checks, what SQL query, what type of SQL operation did we perform? Oh, a quiz. Pop quiz. I've always wanted to say that.
Select.
Select. That's right. So that means that we should have used a get query or a get parameter for that, right? For a password, right? So it is still true that information sent by get is not secure, and that information sent by post is secure, right? More secure, encrypted at least, right? So this is what I mean when I say these are not hard rules, right? You must still be able to adapt to the situation, right? Post parameters are still encrypted, so we need to send sensitive information by post, even if on the inside of the server we're using that to hook it up to a select query, right? Because security always has to be the primary consideration. But secondarily, we should follow these guidelines. Make sense? Any questions? Cool.
So would put and delete also be encrypted as well normally, or does it follow more? Yeah.
It's an interesting question. I would have to do research to answer that question. Oh, that's interesting. Okay, so here's the specification, the actual specification with a few more interesting ones, some more detailed information. So, get, transfer a current representation of the target resource. Get me a copy of that. Head, same as get, but do not transfer the response content. Interesting. So you just get like the header. Head gets you the header. There you go. Post. Perform resource-specific processing on the request content. Here, take this and process it. Put. Replace all current representations of the target resource with the request content. Here, take this and put it here, there, and here. Update operation. Delete. Remove all current representations of the target resource. Here's an IDA. I want you to delete all these. Connect. Establish a tunnel to the server identified by the target resource. This would be like, this is kind of getting into like SSH kind of territory. Options. Describe the communication options for the target resource. Almost like calling help on it. Trace. Perform a message loopback test along the path to the target resource. Kind of back-end servery kind of stuff that you probably don't have to worry about if you're just writing a web application. But yeah, there's the complete list. Question?
So for cloud operations, can we just do post requests and adjust our process based on the path parameters?
Yeah, but you're not being resty, right? Like, basically the answer to that and all similar questions is yes, deviation from like the restful way of doing things is certainly possible, may even be convenient, may even be good programming, I don't know. But, you know, at a certain point it's sparkling JSON and not REST, right? But, you know, to some extent this is correct, right? It's correct to think about request methods this way. This is the way that they were intended and designed. So it's not really like, we're not really trying to impose new semantic ways of thinking of the internet onto things. We're just trying to use the parameters in the header the way they were originally intended. Right? Make sense? Okay. So in PHP then, and it seems like what's happening with today is like today is going to be, we're going through the slides and on Wednesday we'll do the programming examples. Okay? The way that we access our request method in PHP, well, it's part of the server superglobal again, and we will be matching strings the same way that we're matching strings when we're reading out of the route, right? So you'll end up having, probably something like a switch case. You know, if request method is get, here are your options. If it's post, these are your options, right? So we may now be talking about like a switch case inside of a switch case, right? You're switching over your actions for a particular request method, but each of your request methods is also being switched on, right? Does that make sense? Nested switch cases? Sort of? Am I losing you guys? No? You okay? Still good? Okay. Thumbs up? Okay, good. So, consider the following. Our API from previously, but expanded with more operations based on request methods. Notice that the routing the route here is the same in all four of these cases, but the method has been modified. So, get means we're retrieving information from a student. Post, adding a new student using ID given. There will be more information attached to this, probably in the body, probably in JSON. Put, modify a student record by ID. Again, JSON information would need to be attached. And delete a student record by ID. Of course, you don't really need any information about the student other than the ID to delete the student, right? It's kind of the same as terminating a login session. You don't really need any information along with the logout request, right? Make sense? So, but you'll see, if all we had to go on was the URL itself, we would not be able to distinguish between these operations. We now require the request method in order to distinguish which operation we require. Make sense? Okay. So the method which is being recommended in the slides here for finding you know, whether or not the route contains a particular action word or keyword is the string position function. I suppose that's okay, but it's a little bit out of the way, right? Less processing probably, but like the problem, so here I'll here's the problem with string position, right? Let's put some slashes in there just for fun, right? Slashes. I guess that's the escape slash. This is route. Supposed to be the last one. So let's say that the action word that we're looking for is route, right? So string position would say, okay, I've got a match for route right here. That's position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Position 9. That's not -1, so we found it, right? So we found the value. Yay, right? But this is a much more loose requirement than is implied by the API specification, right? Because you would also match on this route sucks, right? And here it would be 0, 1, 2, 3, 4, 5, 6, right? So basically, in order to determine whether or not the string is in the right position, you have to kind of remember what the offset within the string is for that group of characters and how far along it's supposed to be, and maybe that's right, maybe that's not right, you know, like, bleh. Much better to split this into a list of strings and to test them positionally, right? Because, like, the other thing that this matches is like something like this dumb root is dumb, right? Now, for this one, it's like, oh, I've got a match right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And maybe if I remove that, it becomes 9. If all I'm looking at is the position, string position can't tell the difference between this one, which is presumably the one we want, and that one, which is the one that we don't want, right? So don't use this method. Use the splitting it with explode and test each of the individual parameters as a whole. All right. This does not get you where you need to go. Okay. Any questions? It's not a class with me unless I have at least one disagreement with the slides, right? I disagree with the slides because I didn't write them. Yes?
Doesn't using the prefix variable in this solve that issue then?
Prefix. Well,
Because then you've got to have a set prefix, so you would always have this is as a prefix.
yeah, but where are you setting the prefix? You know,
I guess
like,
that's not shown.
I mean,
But like you can assume that prefix is assigned to this is, and then you do string path prefix, which is this is / routes, and you get 0.
okay, here's the reason you don't want to do Like, that's not really, like, you might as well just encode the whole route there, right? There's actually nothing gained by having a prefix variable here, right? Like, you might be able to use it across a couple of these, but like, after you've done the substitution, you're kind of like, you're just testing on a whole string, right? If you break it into an array, right, then like you can do something like a control structure on each level of the, like each thing in the array, and you can like step through it in a way that's like logical and uses if statements, which I personally think is better and more readable, at least in PHP. Like, if we're in PHP, then let's be in PHP, right? If we're in a language that thinks that it's C, then we should program like this is a thing that thinks it's C, right? Which means we should have buttloads of switch statements, right? Because that, it's clear and consistent and makes sense. All of these like little tricks to try to make things look a little bit more like Laravel, it's like, no, go program Laravel if you want to program Laravel, right? Like, if we're here and we have to do PHP, let's do PHP, and not try to like ham-fist PHP into being a framework when it's not, Okay. So, the request body. Again, up to now, for the purposes of certain assignments, when we have been returning information to the client, the body of the response is often just JSON, right? We JSON encode it, we echo it, boom, the body is JSON. Why can't we do that incoming as well, right? Why do we have to couch things in like the post parameters? Why can't we just send some JSON as the body? Well, you can, you absolutely can. It's not difficult at all. If you're doing an AJAX call, you just, JSON dot, I think it's dump string, and then you have your object, and it converts it to a string, you attach it to the body, you send your packet off, and you're off to the races. I think it is dump string. Oh man. I'm about to have an I hate JavaScript moment. Everybody prepare for the I hate JavaScript moment. JSON dot dump string, am I right? No? What is it called? JSON dot toString? No. Parse? Stringify! Oh, it's even worse. Yes. Dump S is in Python. That's the actual name they gave it. Stringify. GIF. Like,
I think that was part of the front end code for some of the assignments, the stringify.
yeah, I mean, it has to be. That's the method you use, right? All right. Did you know that the I think the original prototype of JavaScript was like written in like 5 days or something. So
That makes way too much sense.
yeah. You know the guy who invented JavaScript apologized for it at a conference. That is a true fact.
I mean, doesn't the guy who wrote PHP also just hate it?
Probably. I mean, like, think about it, right? It's like, you have this nice little project, it's a, a personal project, it's like, ooh, this looks useful. People start using it, you're like, yay, people are using my personal project. Then the letters start coming in, it's like, ooh, could you add this? Ooh, could you have that? Oh, this doesn't work very well. Oh, this is not very good actually, this isn't a very good project. Could you make this better? Could you make this good? This is awful. Your programming language you invented is the worst language. Can you please fix it, please? And it's like, no, it was never intended to be this. You guys have taken it and done things with it was never intended to do. You fix it. And that's what happens.
Everything goes in square.
Yeah. So, the question you may be asking yourself, if I were a person who was programming in PHP, how would I get information out of the body directly without having to get it through a parameter? And the answer is, there is a file called php://input. If you read the contents of that file, that is the body of the packet. Once you've read it in, if it's JSON, you can decode it. If it's not, you do whatever. It's a string. It's a string, do whatever it makes sense to do with a string. Just make sure you filter it. Right? Just because it's not a post parameter doesn't mean it didn't originate with the user. And the user cannot be trusted. I want everybody to say it. Who can you never trust?
Fine.
The client. Good. Yes. So, that's where you get it. Again, we'll do an example next class. So, a lot of stuff about this class is like a little strange. One strange thing is like, we're only just now talking about setting content type, right? So content type, it's a parameter in the header, and it tells the browser how to interpret what it's received. It's actually pretty important. You might even say essential. And you have basically what you plug in here is the MIME type for whatever sort of data that you're sending along. In the case of JSON, that MIME type is application/JSON. If you were sending an image, it would be image/GIF, etc. Audio/MP3. But the header function in PHP says, I'm setting this value in the header, please. Give me a string and I shall set it. So you have to remember to spell this correctly, and there's no type checking, right? So there's another nice little bit for you, no type checking, right? But that's how you do it. That's how you set your content type. So if you're sending CSV, tell the client. If you're sending JSON, tell the client. If you're sending HTML, tell the client. If it's doing file serving, it's going to do this automatically. But since we're taking over a certain amount of that now, this is something we become responsible for. Okie dokie? Any questions? Okay. So, I don't think we really need to dwell on query parameters too much, as we have been talking about them all semester. But essentially, this is how you specify query parameters inside of the route. It's called URL here. you'll notice that we have the query parameter question mark, as well as the name of the parameter and some value. This is just how things are specified in the URL, right? For me, because of my personal tastes, I often like put another column in that's specifically for query parameter this, query parameter that. But this is also a way to do it. Response status codes. So, did I show the HTTP tags at the end of the last? Yeah. That might be more informative than this. I'm kidding, of course. So, I touched on it earlier, but in the same way that we should tell the client what the type of file we're sending them is, we should also tell them whether or not their operation succeeded or failed, and if it failed, in what manner. So, for example, the default is OK. Response code 200. This is, if you don't set anything else in PHP, this is what it gives, unless it has some kind of Apache-related error of a different sort, such as a 404 when it attempts to load files that don't exist, right? 404, file not found. The resource you are trying to get or put doesn't exist. There's a whole list of these things. One that you'll probably have gotten quite a lot in this course so far is error 500, internal server error. This is what happens when your PHP script blows up or fails to compile or something like that, right? A lot of the rest of these have to do with networking stuff that we don't care about because we're not networking people. On sort of a normal day, the one that you'll probably see most often that's not 200, which you generally don't see at all because it's the default, is of course 404 not found. However, a fair number of you will probably also have seen 403 forbidden. If I'm on CS Unix and I try and I get an error 400 forbidden, what have I done? Accessed something you're not supposed to, yeah? What particularly?
Someone else's folder. If you're trying to access someone else's folder.
Someone else's folder, well, a folder in particular.
Private.
Yes, the private folder, yes. So if you access somebody else's private folder, and then you fail to provide login credentials which give you access to that folder, what you will receive is 403 forbidden. You are not permitted to access the resource. You do not have correct privileges to. Make sense? Okay, cool. Any questions? Yes?
Was HTTP designed with like RESTful usage in mind?
Not originally. There's been a lot of stuff that's been added to it over the years, right? Basically, if we take a look through this list, a lot of this is definitely like file server specific. But if we start scrolling down the list, we'll see stuff that looks more REST-y, right? One that kind of sticks out to me as being kind of like REST API-ish is failed dependency, which is supposed to be given if a previous request failed. So if you sent a request, that request failed, and then you sent another one expecting that one to have gone through, that's like a 424 is what you give in that case, which like kind of suggests more of like a API kind of access to me, right? But yeah, like the internet has been a process of evolution, right? The internet did not originally come with cookies, right? The internet did not originally come with JavaScript or CSS, right? When it was first sort of came into being, HTML was it, right? I mean, when the internet first came into being, it was like what do they call it, Usenet or something like that? Yeah, there was like, I mean, it was originally just like a network that was used by, you know, a bunch of eggheads at universities to send files to each other. But like in those days, it was notoriously unreliable, right? Like, have you ever heard of SneakerNet? SneakerNet is putting your file on a disk and walking it where you want it to go. And in a lot of cases, it was significantly faster than the internet. Like, there was a period of time during the internet where it was faster to fly something to Japan than it was to send it via the internet to Japan, right? Now, you know, Japan is kind of an outlier because it's the long way away from, you know, North America, right? It takes like 2 days to get there on a plane, but you know, the 80s was just full of, you know, business guys with floppy disks in their briefcases. Yes?
Yeah, I was just pointing out, that kind of happened recently with that first image of the black hole. We heard about that, but the disk was so large with so much data, and how it was set up with all these sensors around the world kind of mimic a large mirror. That they had to do it physically rather than over the internet.
Yeah. I mean, it's kind of crazy that such applications still exist, but like, I mean, a thing that we're kind of finding out about the internet in recent months and weeks is like, the internet is subject to this kind of universal law that the more complicated something gets, the more complicated something becomes, the easier it is to break it, right? Like this was true for all of us back in the nursery when we were building our little wooden blocks, right? The higher you stack your tower, the more likely it is to fall.
They have an XKCD for that, the all modern digital infrastructure being built on like one tiny little block.
Yes, yeah, and did I talk about I talked about that exploit that just about happened with SSH, right? Where it was like arbitrary code execution hack that like got snuck in by like a mysterious shady person because like a whole compression library that SSH depends on is like maintained by like one guy who does an open source project, and like he was like, someone wants to help? Their code isn't bad? And it's like, I can't believe someone's finally helping me. Turns out that what that person was intending to do was put a backdoor into SSH, which they just about managed to do, except basically some security testers who test Debian noticed that like the SSH protocol was taking like 0.2 seconds more time than it normally took. So they were like, we should dig into this, and it turns out there was an arbitrary code execution exploit that was built into SSH that would have given people a backdoor. Yes?
It was actually just one guy,
Yeah,
not even a security researcher.
yeah, just one guy. Yeah, like, yeah, no, it's true. Like, always be grateful because it's a miracle that anything works at all. No, I'm like, always be grateful because it is a miracle that literally anything works at all, right? You know, people think that there's some kind of like, you know, there's some kind of antagonistic relationship between science and religion. It's like, no! When things work in science, it's a miracle. And I mean that in the religious sense. So, alright. HTTP status codes. And yeah, I think that's all we got for today actually. That'll do.
What's insomnia? Is that like a
Oh, it's a thing that you can use to fire off packets, like an older version of Postman, I think.
okay?
Yeah, I installed it once and regretted it. Actually, I regretted it because of the icon. Like, the icon for Insomnia, it might be different now, but at the time, the icon for Insomnia was like this unblinking, unsleeping eye that was watching you.
A Sauron eye?
Yeah. Insomnia cookies? Come on, that's just cannabis. Come on. Insomnia cookies. Give me a break. Insomnia, what do you, application?
.rest.
Insomnia.rest. Yeah, there it is.
Still looks
That
like an eye,
creepy
but it's
thing.
less threatening.
Yes, look at it. It's like always watching, always watching. Yeah, it's just, you know, pretty much everyone uses Postman these days, right? You guys use Postman? You guys have no idea what I'm talking about? I'll show you what Postman looks like. Yeah? Some of you figured this out during like the Ajax assignment in JavaScript. AI needs to die. Anyway, yeah, it's just it does essentially the same thing as Insomnia. So basically, it's a tool for like designing an API, right? You may find it annoying to have to write a fetch request, right? Fetch requests are kind of annoying, right? Here, you have like an interface and stuff, and you can write code, you know, you can set up an API call, and it even generates the JavaScript for the fetch request for you, right? This is how all the cool kids solve assignment 5 in the JavaScript class, which is probably why that assignment, just like the previous assignment for this class, the previous final assignment, needs to die. I love killing assignments, I just don't have the time, you know? But yeah, honestly, this is probably a tool that we should like cover in class and stuff and use rather than just pretending it doesn't exist. Yeah, all right. Any questions? Yes?
What's status code 418?
I'm a teapot? Yeah. There's another out of context clip for you. Yes, 418, I'm a teapot. The explanation I've heard of this is that server refuses to brew coffee as it's a teapot, right? So basically, you're asking me nonsense. You're asking me for something like, it's not just that I don't have this service, you're asking for the wrong service, right? So it's kind of like, it's your passive-aggressive kind of snarky HTTP status code when someone's asking you asking complete nonsense of you. But, yeah. Any other questions?
If there were an HTTP response code, just ask you.
Yeah, well, I
I
mean,
appreciate that.
when deserved, right? Not otherwise. Well, next week is review. So this is kind of the end.
So what are we covering on Wednesday then? Is there more?
Code examples for everything we've done, yeah. Code examples for everything we've done. If we have time, maybe I'll like whip it up into like a little Twitter thing, you know? Basically, like, this semester I introduced the MVC slides. Normally what I like used to do with that free week was we did like a great big we'd make Twitter type thing. But you know, so it goes. It's better to have been properly taught MVC architecture. So yeah, Wednesday we'll do code examples for everything. And that's it. Thank you very much. I guess that's it if you don't fail the exam. If you do fail the exam, I'll be seeing you again.
This is a threat.
Just think passing thoughts and you'll be fine, right?